Hello, hello. All right, so we're going to actually make this game work this time, right? um, if you recall from last time, we had the uh, create random boxes function that we created, and we basically just took in the number of boxes we wanted and used this shuffle array function to just randomly mix up the numbers 1 through 100 in this case, or 1 through 50, or whatever the num variable is that's passed in here. So here we actually passed in the number of students, right? So we call create random boxes with number of students being 100 in this case, although it's whatever I change this to based on this line right here. You can see that we actually look through and find the number of students and get that into a variable, constant in this case, and then say, okay, create random boxes with that number of students. So that creates an array. So this variable holds an entire array with those square brackets, is how JavaScript shows that, of 100 numbers. In this case, we filled it with the numbers 1 through 100 and then mixed them all up. So that's where we're at right now. I will say here that we might want to actually move this line down a bit. We have our error checking here. It's fine. I can create a bunch of random boxes, you know, as long as maybe it wasn't negative. This check does protect me from a negative number of students. If I entered -5 here, this might go badly, right? Run. Number of students can't be less than 2. Cool. My create random boxes function apparently didn't crash with -5 for good reasons. But it's usually safer to do all of the work after you do all the error checking. So that's just a general safety tip. We're going to move this line by cutting it just down after the error checking. This tends to be better practice of where we want things. And now that we have our boxes, we're going to actually let our student play the game. Students plural, yes, but we're going to start off simple like usual. Let's actually have one student just go in, open one box, and just say, did they win or not? That's all we're going to do with our function to start with. So I'm going to come down here and make a new function. I'm just going to call this play one game for student. You can call this whatever makes sense to you. Play one game for student. Now, this function is going to need two things. It's going to need the student number, like which student's playing, student 1, student 5, because, they need to find their own box with their own number in it, so we need to know which student it is. So I'm just going to call that S. I could say student if I wanted to. I'm going to be short because, I don't know. Maybe I'm lazy. Second thing we need to know, boxes. We actually need to know what the boxes contain in them. We, spend all this time making a 100 different boxes with random numbers in them. We need to know that information too in order for this to work. Okay, so that's what we want this function to do, play just one game for the student. And that will mean opening up to 50 boxes in the end. But as I said, we're going to keep even this function simpler than the name suggests for now. We're going to actually just have it play one box for one student. So let's have the student choose a box. I'm going to save the box into a variable called chosen box. So let chosen box equals, and let's just say I'm going to have them choose box 1, very boringly for the moment. That's not obviously random at all. We're going to make that random in a second, but let's just have them choose box 1. And now let's go look inside box 1. This is where things get mildly interesting because we have to remember how to access things inside an array. If you remember right, boxes is a list of 100 numbers. How do we go get box 1 from within the boxes array? So I'm going to say let box contents, making another variable, equal. And this is how I go get the first box. Boxes, chosen box, -1. And the semicolons are at the end like usual. So why the -1? Remember from last time, arrays in JavaScript and most computer languages are zero-based. The first element is a 0. So when I say chosen box is actually the first box, 1 through 100, if that's how I'm considering my chosen box to be 1 through 100, then I actually need to access 0 through 99 in the array because that's how the computer counts. Maybe frustrating, confusing, I don't know. Again, legacy, old computer reasons and memory layouts and weird stuff like that that just mean that this is what we're left with to deal with. Yay. Okay, so, and remember the square brackets? They were used in two different ways. One was to say this is a list of things with commas in between them. And the other way that we see here, as we talked a little bit about last time, was if they're right next to the variable that's already an array, then they access this single element, this single place in that array, in that list of numbers. So when I say boxes, chosen box minus 1, it takes chosen box, which is 1, subtracts 1 from it, gets 0, and says, give me the number inside the 0th position of boxes. So if boxes got all mixed up and 92 happened to be the very first number and a whole bunch after that, then boxes 0 would give me 92. And 92 would then get assigned into box contents. So, assuming we choose a box randomly in a bit, this will just, between 1 and 100, this will subtract 1 from that to get it to the 0 to 99 range, grab that position wherever it is in the list, and take the number there and shove it into the box contents variable. And that's what we wanted. We wanted to know what number is in that box. Okay, so did they win? So I need an if statement here. So we've seen if statements before. We saw them above with the error checking. But basically, we want to say, is the student number equal to the contents of the box? If the box had 92 in it, is the student's number 92? Well, the student's number is just S. So if I can say if, and I need my brackets or parentheses here, box contents, whoops, I can't spell, contents, and remember the double equals. It's always important. I know it's an easy thing to trip up at first. So this says, compare these two. Are they equal, yes or no? Rather than box contents should be assigned the value of S, right? We have single equals as always generating an assignment. Take this contents and shove it into this other variable. This keeps that distinguishing separate to say, no, I'm comparing them, not assigning anything. Yay. So if box contents equals S, yay, the world is good. The student has found their number on the very first shot. They opened box 1 in this case, and we're just like, wow, I am student 92 and it has a 92 in it. I am happy. So in this case, we're just going to return 1. They won. So they have 1 win. Yay. Nothing fancy there. Remember, returns return a number from a function. So when you call this function, you'll usually say let some variable equal the return value of this function. And then this variable will capture the number 1 if they happen to win. And unsurprisingly, we'll return 0 if they didn't win. And that's it. That's the student opening 1 box and seeing if they won or not. Now, there's 2 things to finish this off. Let's actually pick something besides box 1. We need a random number, right, between 1 and 100. Well, we wrote that function too, if you recall from a previous time, right? Up here we have, too far, random num, this one. We can pick any random number between A and B, including A and B. That's how we wrote this function. So I basically just need to say, give me random number 1, 100, and that will give me a random number between 1 and 100. Or, more generally, between 1 and the number of boxes, right? So here, I want to say, instead of 1, give me random num between 1 and, I would say 100, but I actually want the length of this box's array. If there was 2 students, let's say here, or 4 students or something like that, then there would only be 2 or 4 boxes, and I only want to pick a random number between 2 or 4 in that case. So again, from last time, we talked about arrays. The way we get the length of an array is by saying the array name, boxes, and then dot length. That will actually be 2 if there's 2 boxes, 4 if this is a list of 4 numbers, array of 4 numbers, 100 if it's 100, 1,000 if it's 1,000, things like that. So this is what we actually want to generate our random number between. Cool. So that finishes off this function. We haven't called it yet. We haven't used it. It just sits here kind of, if you remember right, anything with function in front of it just defines a command that the computer is ready to do something with, but hasn't done anything with it yet. So let's come up here to our run function. If you recall, we do our error checking at the top. We create our boxes, and it's after we create our boxes that, of course, we want to have the students start playing the game. The boxes have been all set up in the classroom, that kind of thing. So let's say let students 1, we want to know how many students have won, equal, and then call our function. Play 1 game for student is what I called it. And then what student are we playing for right now? Well, we're just playing for the first student. So I'm going to always just put the number 1 in here for now. Obviously, we'll play with more students in a little bit. They'll be able to all play the game shortly. And the second parameter is the boxes, right? It needs to be the list of all the boxes we created. Well, that's called boxes here. So be it. So I pass in boxes here and then put a semicolon. These happen to be the same name, but they don't have to be. I could call this boxes 1, 2, 3, 4 and boxes 1, 2, 3, 4, and this would still work, right? It's nice to call them something similar sounding if they really are the same thing, but this is just a reminder that variable names inside functions are completely separate from the variable names of variables outside the function, as long as they're not global. If they're at the very top of the whole thing, like error text or error tag, that's consistent throughout your whole program. But this, if I scroll down here, this boxes variable was declared right here. So it has no bearing whatsoever on the name of this. They are not linked in any way by name. It is just by position. This thing is being given as the second thing. It is just shunted right into that second thing by the fact that it's the second thing given in this list. But I'll call it boxes. It's fine. Okay, so with all that, there's one last thing I need to change here. I need to say, okay, I'm no longer to put number of students here when I press the run button. I'm going to actually just show students 1. Right? I want to show this is only returning a 0 or a 1. How many wins did I have? If this first student goes in and opens the very first box and just happens to win, well, we've got 1 student who won, right? Not all 50 yet, but at least 1 did. And if they don't open the first box, at least for now, if we just stop the game right there, 0 students have won. So it's very simple. 1 student going in, making a YOLO attempt to have 1 box, and just let's say if they won or not. So that's it. Let's run our game and see if it works. So I'm going to click this, and you'll first notice that we're getting a whole lot of zeros. That's probably expected, right? We have 100 students. We asked student 1 to go in and open a random box and see if they happen to get the number 1 in it. There's a 1 in 100 chance of that happening. So I could hit this number a lot. Yep, you saw the 1, maybe. And you'll see 1s every so often. I can, of course, reduce this number to something much more reasonable, like number of students 4. Let's press run on that. Okay, got a 1, got another 1, got a few 1s there, got another 1, but I'm getting some zeros too, as you can see. Oh, getting a lot of zeros in a row suddenly there. So this is odds. Wow, that's a lot of zeros. So yeah, this is actually doing the right thing. I mean, it seems to be doing the right thing at least. Basically, we have a student that is every so often winning when there's only 4 boxes. They go in and find the number 1 roughly a quarter of the time, right? So this is going to happen roughly a quarter of the time. Cool. So the next thing we would want to do is actually have them open up to 50 of the boxes. So we're going to need a for loop for that, right? Sounds good to me. I need to get half of the boxes, right? So if it's 100, I need to only open 50. If it's 4, I need to only open 2. So we're going to add a new variable in here. I'm going to say up here at the top, let boxes to open equal And I'll just say boxes.length divided by 2. I'll have the computer do the math for me. So if boxes.length, if there's 100 boxes, it'll divide that by 2 and say boxes to open is 50. If it's 4 boxes total, we'll divide that by 2 and you say there's 2 boxes that this student gets to open. Okay, so we have that. Let's write our for loop now. So what is our for loop going to be doing each time? How much of this code should our for loop be working on? And the answer is, well, they're going to be choosing a random number between 1 and 100, and they're going to be doing that up to 50 times. They're going to be looking in the box, seeing the box contents, and saying, is that my student number? If so, one student has 1. Notice it's still 1, no matter how long it takes them. Like if it takes them even 50 tries, they only return a 1 still. Only one student has 1 so far. Otherwise, they return a 0. I didn't win. So we're going to keep that part, but notice all of this code is going to go in the loop. We want to do this 50 times if there's 100 boxes. Choose the box. Open the box. Look in it. Is it me? Yes. Go. Return. At the very end, we don't want the return 0 there. Only at the very end of 50 boxes do we know we've lost. And at that point, we admit defeat. We return 0 and say we didn't win. Sorry. So this is where I'm going to put my for loop, right here. So let's do that. I'm going to make one more line here just to keep that separate, just for nicety of looks. So I'm going to say for, and notice I'm going to put some stuff in this brackets, or parentheses in a second. I'm going to put my curly braces here around the whole loop and indent this, because this is typically nice form, again, for loops and things, if statements, things like that. You want your code indented. So notice I can just select this and tab and then shift tab, and this goes back and forth, which is really nice. So yeah. All right. So this is what I want to repeat. How many times do I want to repeat it? Boxes to open number of times. Okay. So this is probably getting a little familiar, but let's just make sure. Let I equals 0. That's the initialization. That's run once before the loop even starts. And then I want to keep looping while I is less than boxes to open. And then I want to, at the end of every loop, increment I by 1, increase I by 1. Again, that's the shorthand I++ notation. So again, this is a 0 counting array here, you'll notice, right? I0, I less than boxes to open means that if boxes to open is 50, this will start at 0. Then it will go to 1, 2, 3, all the way to 49. It'll still run because 49 is less than 50. And then at the end of the loop, it will come back and I will be 50 and 50 is not less than 50, and that's over. So 0 to 49 is 50 numbers, believe it or not. Again, this is weird computer ways of doing things. It is totally fine if you want to say I less than, or I equals 1, I less than or equal to 50. Both of these work. We just need something that loops 50 times in a row. So either of these works. It's more common to see this in computer science. Again, because people are so used to arrays counting at 0 and counting at 0 in general in computers, they just naturally do it. It tends to make the math a little nicer sometimes. So I'll use the common strategy here, but do either that you wish. So now let's play the game again. We have our loop. We're going to actually now have this function doing what we said it was going to do. It's going to play one whole game for a single student. They go in, they open up to half the boxes, and the second that they find one, even if it's the second box or the first box or the seventh or whatever they open, notice the return statement breaks out of the loop immediately. So we don't bother trying more boxes. We just say, bust out now, student 1, we don't need to open any more boxes. This is just like in real life, right? The student's not going to keep opening boxes if they find it. So this is both efficient and accurate to what humans would do. And notice at the bottom, we still return the 0 if they fail. So let's click run on this. I'm clicking run. Notice I'm getting, even with 100 students, more wins, right? Should be getting roughly half, you would think, right? It turns out it's a little less than half, and we're going to discuss that in a moment for reasons. But at least you can see that even with 100 students, we're actually getting a reasonable number of ones where we weren't before. Same deal if we choose down to 4, we're still getting a reasonable number of ones. So now we actually have this function working as it's intended. Okay, so real quickly, why is it less than half? You'll notice here that this is not quite doing what a real student would do in terms of randomly choosing a box. Well, maybe it is, but we were assuming students had perfect memory. If they opened box 5, they wouldn't go back and open box 5 again. That's not true of random number between 1 and 100, right? This could give us 5, 7, 12, 5 again, 12 again, like 1, and then 72, and then 7 again. Like, this could have duplicates in it, right? It's just picking a random number 1 through 100 multiple times. There could be repeats. Now, again, a real student might actually forget after the 17th box or whatever which boxes they've exactly opened. We were assuming they don't in the original framing of the problem. For now, we're going to show what happens if they do. What if their memory is kind of bad? So that's why the chance is less than half. They may actually open some of the same boxes again because they don't have any memory right now. We're going to fix that in a separate strategy. But right now, our random strategy, which is the first one we've picked here, is going to be this. It is going to be just go in, pick 50 random numbers. Some of them might be duplicates, sorry. And, see if we won.